Hi, welcome to my second video, and my sincere thanks for your attention. Here I'm going to explain very briefly my experience in some of the most interesting topics in the sciences that have challenged me and somehow raised questions that I want to answer with the help of this master degree, its course content, research work, and the support of the professors and classmates. One of the most challenging areas that I have worked on was the Gulf of Mexico, specifically the Mexican Salt Province at the southern part of the Gulf. As you can see here on the left, the area is dominated by salt tectonics, so the seismics present very complex features. Now, this is a 3D seismic line. Notice the presence of salt bodies in the upper part of the line, and also notice that there is no seismic image at all below each one of these salt bodies. This is a pre-stack time migration line. This is another line of the area, a pre-stack time migration line too, and we can see the formation of salt canopy here, and also we can see that we have a word signal to noise ratio below the salt. So this line represented a challenge for me during the interpretation. For example, this was the result of my interpretation work on the lower Miocene horizon. You can notice the presence of many gaps here that represent the uncertainty zones and areas below the salt bodies. And this is one of the best lines, a CBM pre-stack depth migration line. There is an improvement in the frequency content, as you can see here, compared with the RTN migration. Even though this line looks good, with a good signal to noise ratio, it has issues. For example, here in this area, we can see there is an issue that looks like a muting problem. Maybe they let pass too much stretched. Another issue here on the left, we can't see the base of salt. And there is some issues here, so we can see these crossing reflections here that looks like the migration operator. This could be anything from velocities to offset content to azimuth content. Could be anything. And this confused the top of salt interpretation. Finally, this is the best representation of the area that did the job, worked very well. However, I kept some doubts about the origin of the allochthonous salt. For example, here I'm not sure this is a welding zone, looks like a welding zone, but I'm not sure if we have instead we have a feeder from a contractional fall here, because we can notice a compressional stress from with a west and east direction. Here too, I'm not sure if this allochthonous salt comes from this feeder here, this welding zone here, or from a feeder. Same case here. This looks like a compressional fault. And another doubt is the base of the autochthonous salt is not flat. So I'm not sure if this is a velocity problem or is we have some kind of structural setting below the base of the salt. And about the continuity of the salt base, I think that a machine learning program could do a good job here looking for the continuity during the processing stage here. It could be a little more difficult for the allochthonous salt, but I think that it could be work well in machine learning implementation here. So this is the kind of doubts that I have during my stage in salt tectonics in the Gulf of Mexico that I want to resolve during my master degree. Another project that I've been working on during these months is related with my first master degree dissertation in the northern part of Mexico. During this dissertation work, I touched many topics related with structural analysis, as you can see here. I touched also backstepping and restoration steps. Here I show the stages of the restoration work. I also work in stratigraphy and sequential stratigraphy. Here I made the syntax and interpretation for stratigraphy analysis. and then sequential stratigraphy analysis and high stand to low stand tract identification. I also work in the lithostratigraphic analysis of different formations and the respective seismic interpretation. Also depth conversion and velocity analysis for time to depth conversion. I also work in seismic attributes, trying to identify the best attributes for sweet spot location. And I also made APU analysis of the area because I had enough data to make this kind of analysis. As you can see, the scatter conditioning work, angle analysis, synthetic analysis, tuning, and AVIA anomaly identification. And finally, I made some work in seismic inversion, elastic inversion, which I show here, and pre-stack simultaneous inversion. And I got some interesting results that allow me identify areas of gas and their extension. And finally, I constructed a geocellular 3D geological model. Now, why I want to do a revision of this part of my thesis? Because when I did the backstepping part and the restoration stages here, I didn't have a specialized software or a tool with good accuracy to make all these restoration steps. Now that I have the software here, I want to be more precise with the restoration steps, as you can see here. All the steps I'm doing to restore the area of analysis that I worked during my first master degree dissertation. And also I'm making some modeling, some forward modeling about the area along with the restoration steps here. Because the restoration process and backstepping analysis could take a long time and also requires a lot of trial and error of settings and algorithms. I think that could be a good idea to implement a machine learning approach during this kind of analysis. This could reduce significantly the times when someone have to do this kind of work. And finally, there is another area that was very complex to analyze and interpret, located in Bolivia, called the Subandean Basin. This area has very steep topography and a very complex geology, as you can see here in the pictures. Because of that, we have many problems with the seismic. So below the topographic heights, we don't have a very reliable image. So maybe we have some indication with each one of these indication could be a product of interpretation of velocities during the processing stage. So that's why we have different processing works from different companies, and each one gave us a different response of the dipping of the reflectors. Almost none of these processing works fit with the dip meter of the well. So this is a challenge that we are facing during the analysis of this area. As you can see here again, different processing during the processing works have different responses. So one of the questions that I want to answer with the help of the university and master studies and a lot of research is if we have a seismic with an offset of 15 kilometers and a fallout more than 400, why we don't have any signal, even with a PSTN processing and RTN processing and a very good velocity model. So what caused this image problem and what we can do to reduce the uncertainty. Most of the geologists use uh, balancing and restoration to get at the best constraint model below the highlands and inside the complex geology zone. But this is an interpretation, and there is a lot of different interpretations here. So my thoughts is that maybe we can implement machine learning to try to get a best balancing and restoration by trial and error, reducing the interpretation time, and also maybe machine learning could find the best reflector response during the processing stages, because the crucial part of this kind of processing is the velocity analysis. This is a very subjective step during the processing. That's why this is one of my projects that I want to analyze and work on. For example, this is an excellent and very complex work of balancing and restoration and petroleum system analysis in Bolivia and sub-Andean basin. As you can see, there are many stages of balancing and restoration, but most of these one are interpretation using a very bad seismic image, and using two geological information. So the idea here is trying to reduce the uncertainty in the areas where we don't have seismic image. And that's why I'm looking for a master degree to gain the knowledge and the skills to reduce uncertainty in these complex situations. So this is the end of these two videos. Here I explain some of my goals, my future projects, and some of my skills. I really appreciate your time and your consideration. And again, thanks a lot.